So good morning, also from my side. Today I want to show you two of our album modules for concrete design in RFEM. So I will talk about RF concrete surfaces. At the first, this module is for design of concrete surfaces, as the name says. And the second part will be the module RF Punch Pro. For this presentation, I have already prepared this example here. You see it in the background. That is a little example, and at the beginning I will just say some words to this example here. We have a base plate here. A slab for the roof floor, some walls, and some columns. I can also check this or change this view here to this solid display model, so it looks like this here. And today I will do the designing first for the upper floor slab here in concrete surfaces, and after this I will do the punching proof for these nodes. So once here at the corner, the wall corner, and then here, and here at the wall ends. So that is a new feature in RF Punch Pro. In the previous version of RF Punch, it was only possible to do the design in the column heads, so in situations like this here. But with Punch Pro you are now also able to do the punching proof on wall ends and wall corners. So that will be the second part. To the model itself, I have prepared here this model with some load cases already. So you see here this is the load case 1 with the third weight. And then I have prepared here 8 load cases for the imposed load or live load. Just quickly switch through the single load cases so you see in which areas this load is acting on. And I have also used the automatic combination of RFEM 5. But compared to Walter's presentation, I don't use the load combinations. I have used the result combinations in this example here. So that is basically the same as the whole model, and I have already calculated the results here. Once for the result combination 7, it's the result combination for the ultimate limit state, and then I got also 3 result combinations for the serviceability. It's first one is the characteristic one, then we got the frequent and quasi-permanent. We will use the result combinations 8 till 10 for the serviceability limit state designed in RF concrete surfaces. So, we can directly start the design in RF concrete surfaces. To do this, you can use this menu here, add-on modules, to open the module RF concrete surfaces. That's one way. Another, I think the most common way, is to use here the data navigator on the left side, and under this entry add-on modules you can find also the module RF concrete surfaces. I have prepared already some cases in this module, so the name of the module is written a little bit thicker to show you that you have already entries here in this file. I open it by a double click on the module entry, and we are right in the first case in the module. You see it here above, in the first case, in the table 1.1. In this sheet you have to choose the loading for the design. So I have once here the loading for the ultimate limit state, and therefore I choose the automatically combined result combination 7. Then I can switch here to the register serviceability limit state design, and there I choose the 3 result combinations 8 till 10. So that are the basic inputs in this mask. The national annex is already correct in this example. As I already mentioned, I prepared this example. So if you want to change here the national annex, you just click on this button and you have here a variety of different annexes available for the Eurocode 2. That are the basic entries here. And next I change to mask 1.2. There you find the settings for the materials. I set the material or concrete class already in the module, so I have concrete class C3037. RF concrete surfaces takes this already existing material from RFEM and writes it here in this table, and I can also use this default value here for the reinforcing steel. If you want, you can also change it here. But in this example, that is okay, and I can directly switch to the next table. There you see some entries for the serviceability limit state design. So in this upper part you see all the surfaces of this model. And in the lower part here you see settings for the check of the serviceability limit state. You see it in this header here. So for example, you can limit for the crack risk control, for example. I leave it in this example like it is and switch directly to the reinforcement. And RF concrete surfaces is working with reinforcement groups. So by default you have one reinforcement group. I've gave there the name or the description roof slab. And by default there are also all surfaces chosen. So in this example I just want to do the design for the roof slab, so I can uncheck this all here and delete all surfaces and set surface number 1. Confirm this is okay. And now in this reinforcement group I just do the design for the surface number 1. So if I go back to 1.3 surfaces and check on this filter here, then you see there is only the surface number 1 used in this case in the model. I go back to mask 1.4 to the longitudinal reinforcement. There you can add some provided basic reinforcement. So in this example I have said that I want to use a diameter of 14 millimeters for the design, and I've already entered this reinforcement areas. So for the top side in direction 1 and direction 2, and also for the bottom side in direction 1 and direction 2. If I need on some points an additional reinforcement, then the program arranges it automatically. And for this additional reinforcement, I will also use rebars with a diameter of 14 millimeters. Now that are my basic entries here in this table 1.4, and I can directly start the calculation with this button here, and now the module is running once the calculation for this upper slab. So the calculation is done. If I click here, it's, for example, on the result table 3.1, you see all the designs, design ratio for this, serviceability, for example. You see that every ratio, every design is fulfilled here. And we can click on the button with the graphics to show you the results on the model. So you see here, for example, the reinforcement governing for the ultimate limit state and the serviceability limit state. I can also choose here this option, selected reinforcement for serviceability limit state. So you here see now in this result view that I have used 12.32 square centimeters per meters as a basic reinforcement, and in some areas the program arranged automatically a higher value. So I can switch through the thinly layers, for example, into the second direction. The program arranged also automatically here in this part an additional reinforcement, and I have here a basic reinforcement of 15.39 square centimeters per meter. So in this example, the program has arranged this additional reinforcement completely automatically. The second option would be that you define the additional reinforcement directly and completely manually by your own before the calculation. So I will show you an example for this. I open the module once again, and I copy this case here in this module. And I switch to the mask 1.4 with the reinforcement. And here is the mentioned option that RF concrete surfaces arranges or determines the additional reinforcement automatically. As I mentioned, we have also the option to define the reinforcement for this design completely manually. To change the dialog here for these entries, I just have to go here on the details, and then you find here reinforcement. And there you can switch from the automatic arrangement according to specifications in table 1.4, that's this table here, to the manual definition. So I change to the manual definition here, and if I click OK, you see how this dialog has changed. So now I have provided a basic reinforcement as in the first example, and with this new area here I can define completely manually reinforcement areas. So I do it as an example here once with a rectangular reinforcement. So I check this on here. Then I can press on this button here, apply free rectangular reinforcement. Then you have to decide here on which side of the slab this additional reinforcement should be applied. So I choose, for example, here the top side, the direction, and then you can set, for example, diameter 14 with a spacing of 10 centimeters, for example. You click on OK. Oh, I just forgotten something. You have now to select the area where this additional reinforcement should be applied. So I click on this button, and now you see the provided additional reinforcement. It's now 0, but I can click here, for example, in this node and open something like this here. Press OK. And if I click here now on this button, show defined reinforcement regions, you see here this value, this 15.39 square centimeters per meters in this area. So you are now totally free in arranging of additional reinforcement. So that is the difference to the first option. The first option, the program defines this additional reinforcement totally automatic. The second option, like shown, is that you can manually define all reinforcement regions. So that is the way how it works in RF concrete surfaces. Because this entry here in this table takes some minutes, I have already prepared for this an example in case 2. Yes. So I switch to case 2 here, go once to the table 1.4, and if I click here now on this button, you see all defined reinforcement areas here. And I can also click here on this button. So now you see all this additional reinforcement which I've defined here manually in the graphics. So I can switch through the directions. For example, at the top side in the second direction, I have defined this additional reinforcement, and on the bottom side I don't need any additional reinforcement. So there is the provided reinforcement, or the basic reinforcement is okay in this bottom side. So with these entries, go back to the menu, and I have already done the calculation here. I can go to the serviceability limit state design. You see here the ratios or design ratios are all fulfilled. And go to the graphics again. And you see now the selected reinforcement for the serviceability limit state design. So I have used, as already mentioned, this 12.32 square centimeters per meters as a basic reinforcement, and in these red areas we have this additional reinforcement. So that was the first step to get the required reinforcement for the ultimate limit state design and for the serviceability limit state design in RF concrete surfaces. And with these results I can now switch to the module RF Punch Pro and use this longitudinal reinforcement for the punching proof. So I switch to the data navigator, and I can open here the module RF Punch Pro. I just choose the correct annex here. So now I have to choose the nodes for the design. As already mentioned, I want to do this in this example for the wall corner and wall end. So I click on this button here. I deactivate just the results of RF concrete surfaces. And now I can select this node, this node, this one, and this one. Confirm it with OK. And for the loading, I'm choosing this result combination 7. And that are the basic entries here in table 1.1. Next to the surfaces and materials. Compared to RF concrete surfaces, or in the same way as in RF concrete surfaces, the module already knows the concrete class, so I can leave it as it is. And also the thickness from the model is written here in this table, so we can use it directly for design. Next to the additional openings. There I can define additional openings which are not considered in the model itself. So if I take a look at this model here, you see I just change the view. That is my roof slab here. And you see in this area I've applied an opening, for example for a stairway. And this opening is also considered in the calculation of internal forces, and it will be automatically considered in RF Punch Pro. But if you have small openings which are not considered in RF Punch Pro, in the model, and you want to consider them in RF Punch Pro for the punching proof, you have to add them in the table 1.3, additional openings. So I can give you a short example for this. I go to the table 1.3, additional openings. I'm selecting a reference surface. In this example, this surface number 1. Then I have to choose a reference node. For example, the node number 5 here. And then I have to define the location of this additional opening. So for example, 0.5 in x direction and 0.5 in y direction, and dimensions of the opening, for example, 0.3 and 0.6. And if you zoom into this infographic here, you see once here the opening which was already considered in the RFEM model. So that opening will be also applied automatically in the punching proof. And here on the right side you see the small opening which was added here. So that is the difference. If you if you haven't entered openings in your model, you can add the openings here in the mask 1.3. For this example, I don't want to consider this opening, so I go here once into this upper table and delete it. And now I can switch to the mask or table with the longitudinal reinforcement. As you can remember, in the RF concrete surfaces module, I have entered a longitudinal reinforcement with a diameter of 40 millimeters. So for determination of the correct statical height in RF Punch Pro, I can modify the concrete covering here for the direction number 2. So I'm entering here 4.4 and 4.4. So if I'm changing these values here, you see how these diameters of the rebars are changing here. Just for example, if I'm increasing that, it changes automatically. So this table 1.4 is not for defining of the reinforcement area itself. It's just to for the definition of the statical height in the concrete covering. So next to the table 1.5, and there we can do some further settings, required settings for the punching proof on the wall corners and wall ends. One new feature in RF Punch Pro is that the module automatically detects the punching shape. So in previous punching module, RF Punch, it was possible to select some nodes, and you had to define whether it is a column on the edge, or in the corner, or in the middle of the slab. Now the module RF Punch Pro detects punching shape automatically. So in this example, for corner number 5, the module detects this walls here, and it knows automatically that it's a punching shape in a wall corner. So if I zoom in here, you see in this graphic here that it is the node number 5, and it's a punching groove on wall corner. So I can click through the nodes here. You see, for example, here it's the number 6, it's the wall end, it's also wall end, and in this part it's also wall end. So I will now do the punching proof for these 4 nodes, but with consideration of the previous calculated reinforcement in earth concrete surfaces. So I click here at first at the node number 5. Then I go here to the details, and in the details for the punching shear design, I can activate here or check on the definition of the longitudinal reinforcement. So if I check it on here, I'm now able to enter here the values of provided longitudinal reinforcement. So for the node number 5, I have used 12.32 and 15.39 square centimeter per meter, so I have to enter it here in this area. Then to the next node 6, also to activate it, and there I enter 18.48, 21.55. And on the point on node number 9, I will also activate it. So these are the values which I've at first calculated in concrete surfaces, and I have now entered this provided reinforcement for the punching proof. So the module uses now this provided reinforcement and checks whether this reinforcement is enough for the punching proof. And if the punching proof on one of these nodes is not done, then the module automatically applies here a shear reinforcement, and in this example it will be a vertical shear reinforcement. So my entries are done now, and I can directly click on calculation and start the calculation in Punch Pro. Yeah, and we directly, the model directly switched to the table 2.1 with the punching shear design and the design criterions. So we can just click through the single results here. You see once here 0.87 on node 5, 0.89 on point 6, and on point 9 I got also 0.85. So on these 3 points, the defined, or with the defined reinforcement, or longitudinal reinforcement, the punching proof is fulfilled. So that's okay. I have only one point here, that is the point number 8 on this wall end, in which the design or shear resistance is not fulfilled with the defined longitudinal reinforcement. So the program automatically applies here shear reinforcement. So you see once here design shear resistance, that is the design with the applied longitudinal reinforcement, and then you see here with a design criterion of 1.0 the shear resistance of the shear reinforcement, and once and the outermost control parameter. If I change to the table 2.2, we can check the applied reinforcement once again. So you see on all nodes the applied longitudinal reinforcement, and on point 8 you see the additional vertical shear reinforcement in these lines here, which was applied automatically by the module RF Punch Pro. So that are my results here. in the module, in the result tables, and I can now switch to the graphics. And you can also display these results here in the graphical view. At first I switch to the wireframe display model and change the view in Z direction. And I can click here, for example, at the longitudinal reinforcement. So you can check here which reinforcement was considered here for the punching proof. You can switch through this. So in the bottom areas I have added no additional reinforcement, so that is written exactly here in this result panel. And I can also switch, for example, here into the design ratios. Could just activate here ISO lines, so the results here. So you see also the result values here in this little brackets here. And that is basically the same which was written in the tables here. You can display the results graphically. As Walter already has shown this in his first presentation, you can use this graphics here for the printout report. So I will also show it once again to you. I just open here this dialog for the printing of the graphics into the protocol. Then I go also to the mass print. And if I go to the results here, then you see all results which are displayed here in the result navigator. You can select all results here for the mass print into the printout report. So for example, I choose the provided longitudinal reinforcement here, click it on once, and then I want also to know the punching shear reinforcement. And what's also interesting for me is the design ratios. So check this on here, and the program tells me that I will get 9 graphics into my printout report. I confirm this with OK, and I say yes, the graphic should be printed as in screen view, so with the same settings here, and I use 50% of the page height in this example. I click once OK. Then I get an additional dialog for a new printout report, and say I just want to have data of RF Punch Pro. Click OK. And you get now all results for the punching proof with the module RF Punch Pro in one short printout report. So for example, we can switch to the shear reinforcement. That is this graphic here. So you see in this graphic that the shear reinforcement is only required at this wall end, and if you want to modify the graphic here after printing, you can just click here once on the graphic and say edit. Then you jump back to RFEM and you can zoom in like this, for example. Then I click back. And the graphic will be actualized here. So that would be the way how RF Punch Pro works. So that's the part RF Complete Surfaces, RF Punch Pro. And next I want to show you how it works, or how the result beam works in RFEM 5. I just close this here, save it, and I will give you a brief demo of the result beam. So I just cancel this visibility mode here and switch off the results, and then we can, I will show you how you can use a result beam to get results on a member which are integrated from surface results. So once I switch here to this working plane and set this grid into this wall here, for example, then I change the distance between the grid points or spacing into 0.5, for example. 0.5. Click on OK. And as next step, I will apply here an opening in this wall. So I switch to this model here. It's better visibility. Then I go here to arrange a new opening. I can use this one here. It's a grid, for example, like this. Yes. And we have now here a new opening, and I want to get the results here over this opening, over this window opening, as member results or member internal forces. So how can I do it? I just create a new line here over this opening. Okay. And then I do a double click on this line, and I check on that I want to have a member on this line. So I activate here this member, and now I have to go and change the member type. By default, RFEM creates a usual beam, but in this example I have to change it into a result beam. So result beam, and then I will create a cross section for this result beam. Here it should be a rectangular cross section, for example, with a thickness of 250 millimeters and a height of 1000 millimeters. Confirm it with OK. With OK once again. And the last step which we have to do here is to tell the program in which areas the internal forces from the surfaces should be integrated to member internal forces. So I click on this button here, edit member type, and you have now to define here an area in which the internal forces of the surface should be integrated to member internal forces. So in this example it is okay if I just say 1 meter, and in this lower part here I can select which objects should be included here for this integration. So I choose just this wall here, wall 3, and no solids or no members, and I can confirm this is okay. Also here is okay, and here is okay. And now you see here the result beam. You see once here with light shadow. This is the just change it. So you see here this light shadow. This is the width and height of the integration area of the internal forces from the surface. And here you see this line that is basically the result beam. The result beam itself has no stiffness. It's just a definition for integration of the internal forces in the surface. If I start now the calculation, for example, in result combination 7, you get here on ISO lines, I just switch it to ISO for example. As default, I will get here global deformations, but that is not so interesting in this for this result combinations. So I deactivate this here, and I activate the member internal forces. So you now see here the moments. For example, for this balance here. So that are the usual members. Was member type beam, and what you now see here is also a result beam. So you see here on this result beam, for example, the moments and so. If I switch through the results here, then you see all, for example, torsion like this, or shear force in both directions, and normal force. So now you can use this member over the window and do the design, for example, in RF concrete members. I just want to give you a short demo of that. I go to the data navigator, search for the model RF concrete members, choose this result combination, go to the reinforcement group, and I don't say that I want to design all members, I just want to design this member here. Press on OK. I leave the reinforcement like it is here in this example, just for a quick demo. Click on calculation, go to the graphics, and if I deactivate this one here and activate the longitudinal reinforcement, you see here the reinforcement which would be required over this window opening. So you have, as user, you have two options. First option would be the design completely with RF concrete surfaces. So you can choose this wall with this opening in this module. That would be one option. The other option is to add this result beam, to integrate these internal forces from the surface into member internal forces, and then you can use this result beam in RF concrete members and do the design there. So there is no right or wrong way how to do it, so you can decide by your own how you decide such areas over the openings. So.